Hey everyone, guess what arrived in the mail this week? A 2.5 watt laser diode, complete with heatsink, cooling fan, and just a single 12 volt connection. I've been able to snap some pretty amazing photos with this in action. The laser also came with a power adapter. This is a mains to 12 volt 2.5 amp adapter. I won't be using this. I'll be powering the laser directly off the ramps board on our 3D printers. Of course, safety first. I also ordered some safety glasses to block the wavelength of this laser, which is 445 nanometers. That's in the blue-violet region of the visible spectrum. I purchased this model from Banggood. However, there are so many to choose from. When selecting a laser diode, there's some features worth mentioning. Power. You can buy these in power ranges from low milliwatts right up to 15 watts. Focus. The laser power is best used if you can focus the beam to a tiny dot. This allows variable heights for the laser to be located and ensures you'll get maximum performance for the power output. PWM or TTL. All of these laser diodes are driven from 12 volt DC, and some allow variable power output by sending a pulse width modulated signal, which typically allows 255 steps of power output. The mount is very basic, 3 by 10 millimeter M3 screws to attach the mount to the rear of the laser, and also 4 M3 hex nuts, which allow this mount to be attached to the X carriage on the HyperCube 3D printer. To control this laser, I'm going to be plugging the 12 volt input into the D9 output of the ramps board. D9 is used for our cooling fans, so I can use the same output to turn on and off the laser in software. But also we can control the power output using the M106 S0 through to S255, so 255 steps of power output on the laser. The actual DC connection here is a 5.5 millimeter barrel connector, so I've just wired up another 5.5 millimeter barrel connector to my ramps board on the HyperCube currently, so I can just plug that in like so and then turn on and off the laser using the M106 and M107 G-code commands. The laser is the first toolhead that requires connection into the ramps board. I've wired this into the same cooling fan output as the E3D uses up here. Obviously, to be able to detach the E3D hot end and attach a laser, it also requires attachment of some screwed terminals on the ramps board. That will get cumbersome pretty quickly. One of the comments on the previous video had a great suggestion to use a universal connector somewhere about here to enable quick release of all the connections to the ramps board. So that means everything on the E3D hot end would go through that same connector. That would allow tool heads to quickly be able to be connected and reconnected without having to wire anything directly into the ramps board. Before we turn on the laser, make sure you're wearing your safety glasses. I can't emphasize that enough. And also ensure that the build surface is non-flammable. Here I'm using aluminium. But if you have a specialized build surface, like this printed Z plate, make sure you remove that first. We'll first test the laser. I'll send command M106 to turn it on, and M107 to turn it off. Before we start etching and cutting with this laser, we've just got to make sure that the laser beam is focused to the smallest dot that we can using the focus ring on the bottom of the laser. Now to do that, we've got to come up with a height that we're always going to use so we can lower the bed to that exact height, then we're going to always be in focus. So for me, I'm going to use 50 millimeters as the height that I'm going to focus the beam. And before I start using this laser, I'm just going to make sure that the laser is 50 millimeters above whatever surface that I'm going to etch or cut. So I've lowered the bed to 50 millimeters. And I'm just going to turn on the laser now. I'm going to turn it on to quarter power And the G-code command for that is M106S64. And you can see it's on quite faint. Let me repurpose this camera to get a better view of this dot. And I'll put the glasses in front so you can just see. So you can see that's a small dot on the aluminium bed. But what if it was out of focus? Well, this is what happens. So I'm now turning the focus ring on the base of the laser, and you can see the dot is no longer a dot, it's kind of a line. And if I focus that again, so now it's coming down into a small dot. There. So that is now focused at 50mm height from the laser. Alright, let's see if we can cut some cardboard. Just got a piece of scrap cardboard here. I'm just going to cut a square out of this, just a 20mm square. Seems about right. I've printed heaps of 20mm cubes, so why not start cutting 20mm squares. I'll just position the laser, position 0, put on my safety glasses, and hit print. Forgot to open the window. Alright, let's see. Yes, looks like it's coming out straight away. Check that out. Perfect clean cuts. That was 3 passes to cleanly cut through that. Could have done it in 2 passes. Moving quite slowly, 10mm a second, or 600mm per minute. And you can see right on the edges there, there's some carbon residue left over from where it was basically burnt through. Next up, a piece of 3mm balsa wood. I'll be printing the exact same G-code file, just the square and 3 passes at 10mm a second. I'll home the laser somewhere about there. Zoom in, safety glasses, and click print. So much smoke! Three passes. Does it fall out? Yes, it does. That is pretty good. Cleanly cut 3mm balsa. Stained the aluminium again. Ah, comes off easily. The next test will be 3mm plywood. This one's going to be a bit more difficult. Other than cardboard and balsa, which is just basically paper mache, this is actually quite dense and takes up to 16 passes with this laser to cut through. I've already done some tests here to confirm that it does work. And just incidentally, if you try to print slower than say 10mm a second, I think these ones here were 5mm a second, it just starts scorching the surface. So you've got to be careful not to cut too slowly. So I'll try again. We'll home the laser somewhere about here. Position 0. Change the G-code to the 16 passes square. Open that up. glasses on, and print. Okay, let's see the result. Is it falling out? Not straight away. So that's the rear side. You can see it's come through. Should be able to push that out. There we go. Almost perfectly through. I'd say it's a pass. I'd say if I gave it, no pun intended, I'd say if I gave that an extra 1 or 2 passes. So 16 is quite a lot. I think that's as far as I can go with this 2.5 watt laser. If you're looking at cutting plywood, you might want to go a bit higher, like a 3.5 watt or even higher to cut plywood. But if you're cutting cardboard, paper, balsa wood, 2.5 watt, plenty enough. To create our design to etch or cut, we'll be using Fusion 360. To begin, we'll draw a box on the X and Y plane, clicking in the center and giving the box the dimensions of 200mm by 200mm. We'll highlight this box, right click and select Construction Lines. This is the size of our build platform. Next we want to draw something to actually etch. Here I'll be inserting some text right about here, and the text will be Tech to See on YouTube. The text is a little bit small. I'll increase the height to 15mm and make it bold. That's pretty good. Click OK and stop sketch. The last thing we need to do is give this some height. To do that, we'll click the extrude button, click anywhere on this text, and give it a height of, say, 1mm. Now we're ready to move across to CAM. We'll begin with setup. The first thing we'll do is select the starting point for our laser. Here it's chosen the center of this particular design. I'm going to select the bottom left as the starting point. So this is where the laser will be positioned before we hit print. For the operation type, I'll select cutting. Moving across to the stock tab, change the stock offset mode to no additional stock and press OK. From the menu, we'll choose cutting. We'll start by creating a tool, and we need to create our laser. Here I'll choose the Create Laser button. Under the Type drop-down menu, choose Laser Cutter and change the kerf width to 0.2mm. Press OK and OK. The cutting mode. There are 3 cutting modes. Vaporize sets the laser to maximum power. Etch will set the laser to half power. And any of these throughs will set the laser to 3/4 power. Here I'll select Vaporize. The cutting feed rate, this is how fast the laser is going to move on top of the surface. Here I'll change it to 1200mm a minute. That equates to 20mm per second. Moving across to geometry, these are the faces that we want to etch with our laser. So I'll just select every letter and number that we've created on here. Move across to the heights. Here we want to set the laser to be 50 millimeters on top of the surface. To do that, the top height will change to 50, the retract height will change to 50, and the clearance height, we'll set that to 0. Moving across to passes, we'll change the sideways compensation to center. And lastly, moving across to linking, nothing in here to change, press OK. I'll reorientate our view and we can see the tool paths are going to be 50 millimeters above where the part is going to be. We can simulate the tool paths by pressing the simulate button and by clicking play. We can see how this is going to be etched with the laser. Moving across to the statistics, we can see this will take 57 seconds. To export our G-code, click on the Post Process button, select the HyperCube.cps file. The links will be in the description. The only thing we need to change in the properties of the HyperCube CPS is the start position Z. By default that's 2 millimeters. Just delete that. We don't need to add any Z height here because we're already setting it to go to 50 millimeters. And click Post. Give it a file name and save. I've loaded the G-code file into Prontoface, or you could copy it to the SD card and print directly. Just before I begin, I'm going to open a window because this creates quite a lot of smoke whenever you burn paper or any surface really. So now I can hit print. Probably too much power on the laser. You can see it started to burn some of the surfaces rather than produce a nice clean cut. Oh yes, it's pretty good. These almost fall out on their own, just need a bit of a helping hand. I guess this would be a fast way to create stencils. And testing out etching on cardboard, if you set the speed fast enough and the power low enough, you can easily etch onto the cardboard without actually cutting through, like I have up here. So this is the same plain SVG file from the previous video. Hasn't cut through, perfectly sharp lines. You can scale this to whatever size you like. The other test I've been doing was with the circuit board. You've got to be careful with, especially with paper, it likes to catch fire, so just be mindful not to leave the laser unattended if you are vaporizing or etching anything. All in all, I'm really happy with the way this laser is performing on the HyperCube 3D printer. I'm especially happy that I'm able to cut 3mm plywood. I'd say 2.5 watts is as low as you'd want to go if you did want to cut plywood, as this square took 16 passes to only just make it through. If you were going to cut plywood, you'd want to up the power to maybe 3.5 watts at the very least. But if all you're doing is etching and cutting softer materials like balsa, cardboard or paper, 2.5 watts is more than enough than you're ever going to need. And I guess the biggest finding from all this is the amount of smoke and fumes that are created while it's cutting. Definitely have a window open at the very least, or if you can, move the entire printer outside. Save yourself all the fumes inside your house. I'll be testing other software and other materials with this laser in future videos, so make sure you subscribe, and if you like this video, hit that thumbs up button. Thanks for watching, catch you next time.